Please accept my apologies for the recent absence in technical output. Health issues necessitated a brief hiatus, however, discipline permits no permanent excuses. We have returned to continue the analysis. The innovator's DNA. Status summary: we have already grasped the genesis. Rimac is not a mere sports car manufacturer, it is a dual ecosystem. On one side, Rimac technology, the brain directing electric mobility for marques such as Porsche or Bugatti. On the other, Rimac Automobile, the validation showcase. We have already understood the structure, but now it is time to understand the architect. Mate Rimac's conceptualization. Let us discuss Mate Rimac, not as the man who achieved success, but as the state of mind that all of us in this automotive art share. He did not reinvent the wheel. The wheel was already there, within physics and electricity. What he did was to question it. He refused to accept the inefficiency of the existing paradigm. And here is where I speak directly to you, engineers, technicians, enthusiasts. That drive, that irritation you feel when a system does not function as it should, that obsession with seeking optimization, is no coincidence. It is the Mate Rimac you carry within. The Creator's Manifesto. Innovation does not emerge from thin air. It arises from our capacity to question the design. You are not mere spectators, you are transformers. In this series, we shall not limit ourselves to admiring the figures. We are going to dissect, under the ESPRN01 methodology, how those physical principles were transformed into an extraordinary system. Let us cease to be consumers of marketing, let us begin to be creators of complex systems. Block 1. Structure and torsional rigidity. The foundation of the Nevers architecture is its carbon fiber monocoque. Its primary function is the containment of the extreme dynamic forces generated by an electric powertrain. Torsional rigidity is not a comfort objective, it is an operational necessity. Any flex within the chassis would degrade the vector control system's ability to apply torque with millimetric precision. The structure must be a body that remains solid and inert against the torsional loads applied during vector acceleration. Block 2. Mass and material optimization. The use of high modulus carbon fiber strictly adheres to the principle of technical density. The engineering challenge is not merely to reduce weight, but to manage the distribution of stresses throughout the component to prevent structural fatigue. The choice of this material allows for a reduction in polar inertia, which is a decisive factor for the agility of a platform handling such high power densities. Every gram of resin and fiber is positioned to support specific load vectors, eliminating excess material that does not contribute to the system's rigidity. Block 3. Structural integration of the energy system and SOC RN01 management. The battery pack has ceased to be considered an added element and has become an integral part of the monocoque. This is the evolution of mobility design. The battery functions as an internal spine. Structural integration. By integrating the pack within the structure, a drastic reduction in the center of gravity and an improvement in mass centralization are achieved. This architecture allows the monocoque and the storage system to act as a single unit under stress, ensuring that the platform's rigidity remains constant despite the electrical powertrain's workload. Management via SOC RN01. This physical integration necessitates a protocol of absolute control. The SOC RN01 is not merely a charge indicator, it is the energy flow management system that operates in synchronization with the monocoque's structural integrity. The architecture allows the monitoring system to maintain a constant reading of thermal and electrical stability under torsional loads, ensuring that energy density remains within operational safety parameters. Without this interconnection between the chassis, structure, and the SOC RN01 control, the vehicle would be incapable of managing power delivery without compromising the energy cell. Block 4. Precision in vectorial transfer. The Nevers structural architecture is the facilitator of the vectorial management system. The monocoque provides the necessary stability for the torque actuators to operate without external interference. If the structure exhibits structural variations, the feedback sensors interpret those vibrations as errors in power flow, which limits the system's responsiveness. The solidity of the monocoque is, ultimately, what allows the vehicle's software to operate at its physical limit, converting electrical energy into motion with an efficiency that defines the new industrial benchmark. Closing statement. We have analyzed the fundamental anatomy and the flow of energy that allows machines such as this to exceed the limits of the possible. However, understanding the component is barely half the work. The true challenge, that which separates an observer from an engineer, is understanding the interdependence of the systems. At this point, the dissection becomes critical. In the next part, we shall move from structural theory to dynamic execution, what really happens in the milliseconds where the software takes control over physics.